Okay, so now I'm going to be doing a fundamental question from chapter 26. This question has to do with Kirchhoff's rules. And it's fairly straightforward, I think, if I did it right. So first, let's solve for this I, because it's the easiest thing to solve for. So this has to do with Kirchhoff's junction rule, which states that the amount that goes in this case, is equal to both of the ones that come out. Or I should say the amount that come out has to be equal to the amount that goes in. So if what goes in is 3, then when you add the two things that came out, they have to give you 3, which is why 3 equals 1.2 plus this I right here that came out as well. And we get an I, or a current, going through that resistor of 1.8 amps. Okay, great. So now what? Well, now we need to find E1 and E2. E1 is right here. Let's find E1 first. So E1 will use this loop rule, right? A clockwise loop rule. So what does this mean? Well, there's a rule that Kirchhoff has, which is the voltage rule, which means that the voltage drop across all of them has to give you 0, which is what this is for. This is my voltages. They have to add up to give you 0. When we look at our way of travel, right? If we go from positive to negative, our EMF is negative. Is a negative E. That's just a rule. If I go in the direction of travel on my resistor, then it's negative. And if I go against it, right, if I'm going this way and this is going up, then it's positive. Okay, so I plug in all my little numbers, except for this one, because I don't know it. 1.8 amps, 17 ohms resistor, 1.2 amps, 23 ohm resistor. All of that has to give me 0. When I do this multiplication, you get 3, and you get your E1 as negative 3 volts. Wait, as positive 3 volts. I did this wrong. Look at that. I just now realized. Because positive 3 volts is your E1. I'm not going to fix that from the other thing. So now, how do we find E2? Well, the same way, using loop rule and the voltage rule from Kirchhoff's. So in this case, E2, we're going to be traveling this way from negative to positive. So we have a positive E2. Then we're going to be traveling in the direction of this current and this resistor, and that's going to be in the direction is negative, plus this EMF that we calculated, EMF1, which is positive 3, not negative 3. Okay, and all of that has to give me 0. So when I did this, it might actually be wrong now. Let me redo it really fast. 1.8 times 17 plus 3, 33. So this is minus 33. 0.6. Let me sure that right. 1.8 times 17 plus 3, and it's a negative. So I get my voltage to be 33.6 volts. So my voltage across that E2 is 33.6 volts. And that's it. That would be E2 and E1.